All right, compound angle formula part 1. So in this video we'll show that cosine alpha minus beta is equal to the product cos alpha cos beta plus sine alpha sine beta. So what you see on this diagram here is a unit circle with two randomly selected points on the circumference. So the distance OB and OA is equal to the radius of the circle, and the length of that is 1. We also define angle beta between x-axis and OB. So this is an angle that is randomly selected, similar case with angle alpha. So each point A and B can be expressed in terms of Cartesian plane coordinates, or we can use polar coordinates. Using the fact that x over r represents cosine ratio and y over r represents sine ratio, we can replace x and y coordinates with r cos beta and r sine beta. Since r is equal to 1, so that simplifies to cos beta and sine beta. So this is why coordinates of point B are cos beta, sine beta. Similarly, we will do the same approach to point A, where instead of having x and y coordinate, we would use cos alpha and sine alpha right here. Okay, so we have to be consistent. So both points expressed in terms of polar coordinates. Now, once again, remember that OA plus and OB is equal to 1. We will be using the distance formula between 2 points. So this is the distance formula right here. So that defines the distance between point A and B. Also, we will be using Cosine law to define the length AB. So there's two ways in which we will define the length AB, using the distance formula between point A and B, and also applying the cosine law. So cosine law statement will look like so. So DAB squared is equal. So the distance, so the angle between side OA and OB is equivalent to alpha minus beta. So the cosine law formula, so OA squared plus OB squared minus 2 OA OB cosine of the angle that is contained in between side OA and OB, which is alpha minus beta. Okay. Now, so this is the definition of d squared in terms of cosine law. This is the formula that defines d squared in terms of the distance formula. Since left side represents exactly the same quantity, so we can say that the right hand side will be equivalent. So let's follow with the formula between point A and B, using the fact that coordinate x and x1 and x2 is cos alpha, cos beta. y1 and y2 will be sine alpha and sine beta. Also, the numerical value of OA squared, OB squared is 1, and so is OA and OB. So the left side will be simplified to the following. So I'm going to put 2 because 1 plus 1 minus 2 times 1 times 1 times cosine alpha minus beta. Now, using the distance formula, you would see the following. Cos alpha minus cos beta squared. So this is the difference between x coordinates plus sine alpha minus sine beta squared. The left-hand side is pretty much straightforward, so there's nothing we can do so far with it. Now, we need to continue with the right-hand side. So, I'm going to say LS equals, because that's my left side right here. I'm going to call it LS. Hope it's not too messy. So left side is equal. I need more space for that. So this is cos squared. I'm going to jump the formula and say first squared plus last squared minus the double product between first and last. So cos squared beta minus 2 cos alpha cos beta. Similarly, I'm going to do with the next binomial square. So sine squared alpha plus sine squared beta minus 2 sine alpha sine beta. Okay, so Pythagorean identity. If you connect cos squared alpha with sine squared alpha, that will give you 1. Same with cos squared beta and sine squared beta. So that will give you 1. So you would have 1 plus 1 on left side, which will be 2 minus 2 cos alpha cos beta minus 2 sine alpha sine beta. So the left-hand side has also a common factor 2. So now we can divide both sides by 2. So, and also positive 2 on the left-hand side, positive 2 on the right-hand side will cancel each other out. So this 2 is gone, and then we divide by negative 2 both sides. So left side now has the following: cos alpha minus beta in brackets, and now this is positive product cos L. Whoops, I wanted to say cos alpha cos beta plus sine alpha sine beta. So there you go. Now we have the statement that we wanted to prove. Beautiful. So thank you for watching this video. And part number 2 will continue with addition formula for cosine and sine. Thank you very much. See you next time. Bye-bye.